I think people that focus on our abilities to pronounce chemicals, uh, and for lack of a better explanation, don't know what the fuck they're talking about. So people like the Food Babe, Paul Saladino, Flav City, these essential dumbasses on the internet with big mouths that obviously didn't pass a basic elementary school education to be able to pronounce things in such a way. But even though there are people with speech impediments that cannot pronounce these chemical names, that should not limit our ability to consume foods. Because in general, when we understand the approval for these foods to enter in our market for consumers, we need to understand that they do undergo a lot of testing, and they have a lot of standards to be able to be considered healthy for human consumption.
I really wanted to have a chat with you because obviously everything that is related to cancer is so much more attraction and much more importance more than ever because of all the nutrition confusion, the different information sources that tell you one thing and tell you the other, and everything seems to be leading to death or cancer or sickness. And I guess it is so important that there is someone who have already dug deep into these topics to actually talk about it. Not very much people actually talk about these things. So I think that is very interesting to hear from you what you have to say. I sort of put together the questions that make sense into an audience that probably have no idea about this topic. Obviously, you can use complicated terms if you need to. I think it is good to sort of familiarize with terms that are utilized in the literature or like in the medical world, but also like understand what those mean. And I think that's why you're an expert on this topic. So
yeah, I mean, that's not to break things up a little bit here too, but like that's kind of why I started my Instagram page. One, which is, something you kind of alluded to, was that no one's really talking about cancer in the way that I do it. And the way that I do it is specifically to break things down in layman's terms so people, even in my own field, can understand things a little bit better, but also people outside of my own field, which is the majority of people, we can all come to some sort of middle ground on understanding the various diverse mechanisms which go into promoting cancers. So that's the whole goal of my page, is to make things somewhat simplistic and provide just the foundations for people to understand, despite the intrinsic complexities associated with cancer biology.
That's awesome. And I think that's one of the reasons why comes the first question on like why you actually chose cancer, why a PhD, how did this come up for you? Like, oh, I really like cancer, let's go for this, or like, how did that?
A lot of it is actually personal, about my entry into examining cancer biology and pursuing it for my own thesis work. And a lot of it stems from my mom had cancer when I was towards the end of my high school. She had esophageal cancer, and she ended up passing away. And now I know that Lane often says, facts are greater than feelings, but this is one of those rare contexts, or I guess few contexts, where feelings kind of stimulated my curiosity in terms of understanding the things that took my mom. But in doing so, I came to understand, just how cancer, and we'll talk about like what cancer is shortly, I think, but just how kind of beautifully complicated cancer biology is, and how the various things that promote cancers, they start from a very basic foundation, and it's kind of like a snowball effect of a variety of different things which promote tumor development. So I got into it for personal reasons because of my mom. But then as I became to understand more about cancer biology, it became therapy in a way. The more I understood, the more I felt better about, the things I didn't understand at the time when I was relatively young, when my mom got sick. And it helped me understand, why therapies weren't working, why she lost a lot of weight. And we'll talk about cachexia, I think, or dramatic weight loss, which is extremely common in cancer patients. Um, and a variety of different resistances that come with therapies in terms of cancer therapy. So
Okay.
that's just a brief overview.
And before cancer was something that you wanted to study, tell us a little bit about Joy before. What
Yeah,
was,
so
what did you study? What was your passions? What was your focus at that point in time, before everything changed for you in terms of what you really wanted to study and focus on?
yeah, no, that's a great question too. So from the time when I was young, I think we all go through this period, especially when we're, really interested in sciences. There was a time there where I was really interested in astronomy, but I'm not the greatest at math. So I realized very quickly that unless I'm doing some form of physics or applied mathematics, I won't succeed well, because I can't do calculus worth shit, for lack of a better word. Um, and so from when I was young, because I realized I wasn't very good at astronomy, I've always been kind of interested in marine biology as well. So actually, when I first went to undergrad, I was enrolled in a marine biology program at a university on the eastern coast of Florida near Daytona, specifically for marine biology. Um, but long story short, I initially enrolled in that school because I had a full ROTC scholarship. So I also have some military background, some leadership training related backgrounds associated with the Army and the Navy. Um, but basically, the military kind of screwed me over, as it does many people. And I lost that scholarship, so I had to transfer to a different school, and they didn't have marine biology at the school I transferred to, which is closer to Tampa area, nearby, where Lane lives, not far actually, in St. Leo, Florida, and that's where I attended St. Leo University, and I got my bachelor's in biology. And while I was there, I kind of pursued the track of marine biology, but quickly realized that given where I was, there wasn't too much funding in marine biology there. And it was a real struggle to try and do like good marine biology related research where I was. And there was a greater drive to do cancer research because of some of the mentors that I had in undergrad, particularly two professors, one, Dr. Ian Duffy and Dr. Audrey Shore, who kind of stimulated my progression into a nearby cancer institute called the Moffitt Cancer Research Center, where I did end up working for a time after I graduated. I got an internship there, studied breast cancer mechanisms in one of the labs, and ultimately wanted to do grad school there, but did not get accepted. So then, eventually I ended up getting a technician position at the Moffitt Cancer Center. And that lab eventually moved to Philadelphia. So that's where I am now. And that,
Okay.
stimulated my progression into grad school.
Very important question. We're talking about cancer. What is cancer? And is are all type of cancers, tumors, these words that probably a lot of people know, a lot of people may confuse and think it's all the same. What is it, and are they all the same?
Yeah, no, that's an awesome question. And trying to make this simple, when we first start learning about cancer biology, one of the first things we learn about is this thing called the Hayflick limit. And actually, Leonard Hayflick was a scientist at the Wistar Institute where I worked. And essentially, the Hayflick limit is this limit where cells can only divide a certain amount of times.
Okay.
And cancer cells, being cells that continually divide, surpass this Hayflick limit through a variety of different mechanisms. And it's not only uncontrolled cell growth, there's a variety of other issues that, again, create this snowball effect that make up cancer. But in general, cancer cells surpass the baseline of normal cellular growth, and they have either metabolic or genetic issues which sustain their growth past this particular limit.
Okay.
Yeah.
And are when we utilize the term cancer or tumor, are they the same word? Are they referring to the same thing, or is it
Um,
something different?
they're kind of the same thing, and not to really add semantics here, but in general, let's just say that they're the same thing for the sake of simplicity, because I do use them interchangeably on my page. But a tumor kind of refers to like a large mass that is growing.
Okay.
And it can be either benign, kind of not too much to worry about. It's not actively growing very much, or malignant, which means that it's actively growing and may be able to metastasize or grow to different types of tissues.
Mm,
So cancer itself is like more of a mechanistic term,
okay.
um, in that when I say cancer, I mean that there's a variety of mutations that make up a specific cancer type. And in addressing your previous question, are all cancers the same?
Mhm.
No. The answer is no. Even if you had two identical twins next to each other with the same type of cancer, both of those cancers would be different depending on the difference in diet, difference in physical activity, even just difference in distance through space. But not to get complicated there.
When you said about cells can metastasize, how does that happen? How can a cell just decide, you know what, I want to multiply and then I want to go to all the tissues I possibly can? Or how do the cell decide which is the organ target that they want to grow again?
Yeah, I mean that's again, these are all very foundational questions of what it means to study cancer
Mm-hmm.
or cancer biology. So what we know currently about metastasis is that it differs from blood-based cancers, basically cancers of immune cells that are flowing throughout the blood, versus solid tumors like tumors of the breast or the ovary or the lung, you know, those specific masses of particular organ systems. But when we study metastases of tumors within the lung or the ovary, in general, there's this mechanism whereby the cells they they utilize this, kind of like there a lot of complicated processes to basically degrade the membrane beneath them. So they're cells attached to a membrane, and nearby blood vessels they degrade the membrane beneath them, open them up so that they can migrate through various tissues. So they change a lot of characteristics to be able to move, or become more motile. And so they degrade their membrane. They adopt characteristics to be able to move, kind of like growing arms becoming more fluid.
Okay.
And then they move through this basement membrane, and they adopt what's called a mesenchymal phenotype. And so I've covered this on my page. It's a process called EMT, or epithelial to mesenchymal transition. And
Okay.
essentially that means that the cells degrade their basement membrane, they adopt movement characteristics, and they move through various tissues, to get to the bloodstream where they can get in the blood and travel to distant tissues.
Is there a specific way to determine where do they want to go, or it's just whatever first organ is in my way, that's where I
Yeah.
go?
Yeah, no, that's a really good question. There's a preference in terms of tumor environment. So as a cell metastasizes, there's going to be some areas in the body where tumor cells of a particular origin survive better than others. So
Okay.
this is why some cancers, like lung cancers, often metastasize to the brain, but not in other tissue layers. And ovarian tissue or ovarian cancers often metastasize to like breast tissue, as an example, or your lung. So there are specific areas that they prefer in terms of the overall environment where they can, gain these metastatic abilities. And then once they get to their favorable or more appropriate environment, they can change or reverse those characteristics to kind of find a new home. So they kind of like get up and pack their stuff and leave.
What are some of these factors that sort of so determine, you know what, I like this area that will be the best environment for me to grow? What is that the irrigation of blood, the particular cells? What is that?
So my level of understanding in terms of the tumor microenvironment is somewhat modest, but in general, I will say that a lot of it depends on the specific resources that we determine experimentally that tumor cells require for their survival. So it could be specific types of fats, specific carbohydrate sources. It depends on the enzymes that are either upregulated or downregulated, higher expression versus lower expression in the cancer cells, that kind of dictate their favorability to move to different tissue layers. So it depends on the metabolism of the tissue where they're going as to whether or not they'll survive. It's kind of like, me moving from Philadelphia to somewhere across the world where it's like a third world country, where they don't have that many nutrients, where, I'm so used to living in the United States, I wouldn't survive the same way that I would there as I would here. So I need to go somewhere in the world where the diet is somewhat similar to, what I currently have, so that way I can support my own biology. That's kind of the same thing that cancers do, just on a larger scale, if that makes sense.
Okay. So looking or thinking about treatment, we know there are many, many different treatments. Like the most common ones we know is chemotherapy, we hear about radiotherapy, immunotherapy, and probably surgical procedures and so on. But what does the chemotherapy or radiotherapy or immunotherapy, these type of cancer treatments, do do for cancer? How do they actually act upon eliminating or treating cancerous or tumors? And is there any factor that you can actually utilize or make trigger a decision tree as whether it is the best treatment for that particular cancer? As we mentioned, that not all cancers are the same, or when it's time to maybe use one of to combine them, for a better word.
Yeah. So again, this is really at the foundation of how we determine therapies to treat cancer, whether or not a single agent is better than the combination of other agents, and how we determine either chemicals or small molecules to target specific pathways in general is upon the experimental characteristics that we determine from examining these cancer cells in both in vitro or in cells, or in vivo or in animals like mice. These characteristics dictate, how we develop therapies. So I studied ovarian cancer for quite some time. So oftentimes in specific types of ovarian cancer, there are issues with DNA repair mechanisms. So basically, the lack of repair mechanisms of DNA in cancer cells, if you don't target it, they can kind of create this environment where cancer cells will continue to mutate or evolve in such a way where specific characteristics continue to favor, the tumor growth over time. So one of the ways that we can target this mechanism is through like small molecules. In particular, there's this one compound called olaparib, which was FDA approved, which targets an enzyme of the DNA repair pathway. So this is a chemotherapy. And we're also finding that, in targeting that DNA repair enzyme, it kills the cancer cells, but sometimes cancer cells adapt to that therapy, because tumors, they're not just one type of cancer cell, because they're all kind of competing with each other for resources, which kind of complicates therapeutic options. So this is where we try and combine like a small molecule with more currently immunotherapies. So we'll combine something like olaparib with an immunotherapy like immune checkpoint blockade, which is, something I've covered on my page, which people can look up, or, a specific term of this is like an antibody that in combination with chemotherapy reduces the likelihood of tumor cells to evolve in a specific tumor and is more efficacious in their combination to treat these types of tumors. But again, immunotherapy, there's a lot of different types of pillars to cancer therapy. And we'll also combine this with something like radiation, which actually further stimulates DNA damage responses. And if we, further damage DNA with radiation, of course, sometimes non-targeted, we can combine it with something like olaparib so that they can't utilize the enzymes to repair DNA, and they continually build up this DNA damage and they'll die.
I
Yeah,
have a follow-up question that just popped in my mind.
sure.
Um, why is it that when we use chemotherapy or radiotherapy, we see people losing their hair? I think there is a question that I always get, and I have no idea why.
Yeah, this is actually something we don't know too much about as cancer biologists. We have some general ideas, but in general, what we do know is that the cells that are responsible for hair growth, they have a really high turnover rate, and that basically means that they're also rapidly dividing because they have to make your hair. So they're very metabolic cells to make your hair. And so when we give chemotherapy, they're targeting these very metabolically active cells. So in this, I'll say that no therapy is 100% specific. It's impossible to be just because of the complexity between your various tissues and often the overlapping biology between different cells all over the body.
Okay.
So because of the overlap between how cancer cells are growing and the high turnover rate between like hair cells, that's the reason why cancer therapies like chemotherapies target the cells or the follicles that mediate hair growth. And so
Okay.
that's why a patient loses hair. And that's why also when a chemotherapy patient or a cancer patient loses their hair, and they get off that therapy, it doesn't grow back the same because the therapy essentially changes the way that those cells mediate hair growth.
Now, I have another question.
Sure,
Um,
keep going.
when we think about cancer, is is the cause of cancer more predisposition, genetic predisposition? You're already meant to have higher risk compared to someone else, or it's more like environmental and lifestyle?
From an evolutionary perspective, it's both. Some people have genetic predispositions, which, as an example, people who have Lynch syndrome have a very high mutation in a specific enzyme. I'm not going to say, it doesn't really matter, but they have a very high mutation rate in a specific enzyme because of a genetic trait that is passed on through generations from parents. Excuse me. I just ate food. But anyways, so they pass on this genetic trait, which kind of makes them more predisposed for colon cancers or colorectal cancers. Lynch syndrome enables people who have it to be more susceptible to a condition called HNPCC, which is a type of colorectal cancer. But that's not always the case. As an example, people who are chronic smokers or chronic drinkers, and we've kind of alluded to this before, people that have continuous environmental exposure to carcinogens increase their likelihoods for developing specific cancers. Now, despite someone's genetic predispositions to develop lung cancers that come from like smoking cigarettes or esophageal cancers, like my mother was a chronic smoker, which was a strong contributing factor, I think, to her development of cancer. But despite these genetic predispositions, it's a lot more complicated than just environment and genetics. It's usually a very dynamic interplay between both of them, and that's something that we've come to understand just studying evolution of species in general. So this is just at a very molecular scale as
Okay.
to how tumor cells evolve. Like my grandmother smoked a pack a day since she was like 93 when she passed away, but she smoked a pack a day since she was like early 20s,
Mm-hmm.
and she died at 93. No esophageal cancer like my mom, nothing.
Yeah.
There's a lot of other factors at play, but it's more than just smoking or drinking.
Now, following that, what you explained would be then something more related to like the quality, let's see if that is a word, of your immune system. Like if your immune system is very, very good at combating and identifying abnormalities in your system, maybe you're able to prevent this from happening, as opposed to someone that maybe has a weaker immune system. Is that a thing?
Yeah, but I am somewhat remiss to say somebody has a stronger or weaker immune system than somebody, unless we know of a specific reason why they have a stronger or weaker immune system, like somebody with genetically, like Hashimoto's disease, as an example, which is an issue with how T cells develop in the thymus, type of immune cell. Um, but I think in general, things that make people more likely to be able to deal with cancers if they should develop in the body are kind of a balanced approach to living, like understanding all the things that govern human health. And this is something I really appreciate from your page, is like trying to nail home the importance of consuming a balanced diet, or consuming a nutritional profile which is balanced to support um, basic human metabolic needs. So, like consuming a lot of fiber has been shown to reduce risks for specific cancer types. Overall, in general, exercise, no matter the type of exercise, any exercise in general, even if somebody can get up and just go on a brisk walk, but it needs to be consistent. So, something you preach on your page too is the importance of consistency. And this is true, whether we are consistent in our dietary approaches or we're consistent in our exercise approaches. We have to have this understanding that we all health wise meet somewhere in the middle, and it's when we kind of pursue these extremes chronically, unless we have genetic predispositions, um, or metabolic predispositions, we kind of increase our likelihood for developing cancers.
You mentioned exercise.
Mhm.
How exercise itself can reduce the likelihood for someone getting a abnormality growing in the body or cancerous cells,
Mhm.
or what is the actual effect of exercise? I know it's probably very complex, but
It is complicated. But as I said, like, so I have a modest understanding of this because I'm not an exercise scientist, but that's why I associate with people like yourself and your team. So that way I can learn more about this. But from what I know, in terms of, or what at least I think I know, in terms of exercise in relation to reducing cancer risks, in general, I will say that, regarding the immune system, your skeletal muscle is the predominant thing that drives lymphatic fluid movement. The lymphatic fluid is the stuff that makes up your immune system, basically, that fluid that transports throughout your body, that mediates the movement of all the different types of immune cells throughout your body, as they develop. And so enabling your skeletal muscle to be active, so exercising, getting those contractions of various muscle tissues throughout your body and growing muscle within reason, helps to promote a healthy lifestyle and reduce risk for cancers, because you're kind of stimulating lymphatic movement. You're positively affecting the turnover rate of a variety of different cell types in your body, so that way they don't get to adapt to various characteristics that come with leading a sedentary lifestyle. So again, and as you might be aware, obesity is a huge risk factor for developing specific types of cancers. Just as even developing too much muscle, like people who are on anabolic steroids have a high propensity for developing specific types of cancers, as well as other, heart diseases. So again, it meets somewhere in the middle. You try and reduce your likelihood of becoming obese, or either too much muscle, and you try and maintain this intermediate balance between your nutrition, your diet, and your exercise, to maintain overall human health, to reduce cancer risks.
I have one last question
Sure.
before we close this bit of general questions and we move to true or false, which is a very fun part of this interview. When it comes to food, and we know that everything we eat is made up from chemicals, and we hear this buzzword and like gurus and people that are influencers that you cannot eat, or don't eat things that you cannot pronounce, or even imagine when you read them you cannot even understand what they mean, so you have to avoid all of those things. So are there any chemicals in food that we cannot pronounce, that are actually carcinogens, or that could be actually something that you need to be paying more attention to or be worried about?
I think in general, our abilities to pronounce word is more of a linguistics issue than it is like an actual problem. I think people that focus on our abilities to pronounce chemicals, uh, and for lack of a better explanation, don't know what the fuck they're talking about. So people like the Food Babe, Paul Saladino, Flab City, these essential dumbasses on the internet with big mouths that obviously didn't pass a basic elementary school education to be able to pronounce things in such a way. But even though there are people with speech impediments that cannot pronounce these chemical names, that should not limit our ability to consume foods. Because in general, when we understand the approval for these foods to enter, as a in our market for consumers, we need to understand that they do undergo a lot of testing, and they have a lot of standards to be able to be considered healthy for human consumption. So what we really need to focus on is that, in moderation, you can consume anything you want. I'll be the first to tell you that I absolutely love ice cream. I eat a whole pint of ice cream of Ben and Jerry's often, but not often enough to give me health issues. And I offset that consumption with exercising consistently and trying to do what I can for my health overall. So again, just to simplify, people who try and focus on pronunciation of chemicals are missing the point. Yeah, they need to more so focus on what it means to maintain overall good human health.
And at the end of the day, dose makes it poison, right?
Absolutely, yeah. So like there's this focus or this study that these zealots on social media, they like to focus on, and it's aspartame consumption. And you've posted on this before, I've posted on this, we've shared our views on this. And there's this one study from I think it's back in like the 80s or 90s or something, but essentially they used a metric shit ton of aspartame to induce cancers in mice. Now, we don't consume anywhere close to that much aspartame within a sitting. And if you calculate the amount of aspartame they gave these mice, it was something like, I think like 333, give or take, cans of Diet Coke. Now, I don't know about you. I physically cannot do that. The human stomach.
I don't know if I could in at once, but maybe during the day, who knows? If that's the only thing I have available, I can drink a lot of it. But I am fine. So
I know you love your Pepsi Max, but it's yeah, we need to stop focusing on the chemical names, and as we've discussed, the dose of something makes the poison. We understand just how much of something is harmful to our health. And, again, meet in the middle, not these spectrums that people
extremes.
Like to live on. Yeah.
Awesome. I find that it's going to be super fun for the audience, which is true and false. So basically what I do is I'll give you a statement and you will let me know whether you think it is true or false, and give me some kind of rational why just to choose to be that particular answer.
I just want to say before we get into this, I have to add a disclaimer here. There are a few things in life that I think are black and white. So I'll do my best to answer true or false. You're going to see me do this a lot. And in general, that's because I don't believe it's black and white. So I'll explain why, though.
That's the whole point of this, because I am really in the same mindset or headspace that there is very few things that you have to have that dichotomous thinking, whether it's this or that, or true or false, or yes, this is just the way it is. But in life and in reality, everything is in like a gray scale, and there's nothing necessarily in one extreme or the other. Most things are context dependent and lie within the middle some way. So
unless we're talking about like specific enzymatic substrates, like very deep molecular things, like fructose is a substrate for fructose 1,6-bisphosphatase. That's exactly a true statement. But like you said, there's so much gray area when you get to bigger picture stuff.
Exactly. So the first question is, or the first statement is, insulin can stimulate tumor growth. True or false?
True. Insulin can stimulate tumor growth. But again, in providing some context there, not all cancers are going to utilize insulin to promote growth signals. So yeah, inhibiting it or antagonizing insulin signaling is something that we try and consider in terms of personalized therapy, whether or not a tumor will actually respond to inhibiting insulin. So we need to determine mechanistically whether or not that would be a good therapeutic target before we go that route clinically.
If you then have a tumor or you've been diagnosed with certain type of cancers, should you then avoid anything that stimulates insulin?
Um, so I'm skeptical of this. I want to say no, but there are newer therapies coming out that are examining dietary approaches in combination with chemotherapeutics, because, as an example, in switching to a ketogenic diet, and I want to say this loosely, for a small period of time, ketogenic diet for a small period of time in combination with a specific therapy, the cancer cells will adapt to that specific diet during that specific time frame, and this will make them more sensitive to a chemotherapeutic. But that doesn't mean that you can just put a cancer patient on a keto diet, because it's going to reduce their likelihood for insulin signaling. It's a lot more complicated than that.
I think we forgot to cover cancer cachexia. And when we get these patients that are super malnourished and they have all the symptoms that are preventing them from eating, nauseous, vomiting, just very low appetite, early satiety, taste changes, metallic tastes, just the loss of the taste, or simply they have more limitations as to what they can eat. How do we go about actually, because this is something that me as a dietitian seem to find very common when I work with patients in the hospital and they have had cancer treatments and they very malnourished. You need to utilize an approach of high protein, high energy diet. And generally, obviously, you try to aim for high quality, nutritious foods that are also high energy dense. But you can't avoid not having carbohydrates or things that are going to stimulate the production of the insulin spikes. So how much is this important when it comes to looking at the entire context of the patient? Is it the same response or the risk of eating or getting these insulin spikes if we have someone who is cachectic or very, very malnourished, as to comparing that to someone who is obese or overweight? And maybe is there a difference there?
To be honest, I don't know. From my understanding of cancer biology, and this is going to be different for you because you understand more about nutrition than I do, and even, I don't know how much you know about like cancer diet related nutrition versus like, so I know you're an RD, but I know that there are people that specialize in specific RD for cancer patients. So from my own understanding as a cancer biologist, humans need carbohydrates to survive. And, despite our abilities to make insulin, whether someone is like pre-diabetic or on the verge of obesity, we have to consider the types of nutrition, like you said, by consuming high protein diets, nutritive, rich foods, to be able to, keep them healthy while they're undergoing therapy. Because, like you said, cachexia or rapid weight loss associated with having cancer, and these types of therapies, they also induce this rapid weight loss. We have to mitigate those effects by having these high protein diets, but we also need to ensure that the cells, which again require carbs, specifically tissues like the brain, utilize glucose as a predominant fuel source metabolically. we have to ensure that they're consuming enough carbs as well as protein to be able to, support muscle growth, maybe try and get the patient exercising a bit as much as possible, which is extremely challenging when you're undergoing chemo with all of these, side effects that often come with it. And it's a complicated problem to solve, but I think in general, people, want to cut out carbs because cancers do also utilize carbs for their own growth, oftentimes more than other resources like fats or proteins even. They can break down fats and proteins for energy demands. But people in general have this assumption that because cancer cells utilize more carbs, it's associated with increased insulin signaling and therefore increased tumor growth because of the things that insulin governs.
Okay.
But it's a lot more complicated than cutting out carbohydrates. We need carbs to survive.
I think that leads to our second question, the second statement, that is cancer and tumors feed on glucose. Hence, sugar itself, the consumption of sugar at all times could make things even worse if someone had any type of cancer. So is that true or false?
Neither. It's in the middle. That's one of those things that's like dead in the middle because again, because of our need for consuming, carbohydrates. Carbohydrates, when we say carbohydrates, it's not just glucose. Just like protein sources, there are a variety of different types of carbohydrates depending on, the chemical structure of carbohydrates. They're glycosidic linkages, which is the chemical bond that, interacts different types of sugars, whether it's glucose, fructose, galactose, all of these different types of sugars. So yeah, that's one of those things that's literally in the middle that, again, these social media influencers try and persuade people that, oh, sugar fuels tumor growth. You have to cut it out like completely. Keto diet's the way to go.
Yeah.
And actually it does end up making a lot of people's diseases worse because, they're not consuming a balanced nutritional profile. They become cachexic, and a lot of these things end up fueling tumor growth because tumors, as I've kind of alluded to, they're very adaptive. So even if you cut off sugar to a tumor, and we've done these in even the most basic experiments, in complex tumor environments, tumors will adapt to the absence of sugar and utilize other sources, amino acids as an example, to support tumor growth. So they'll upregulate enzymes which break down proteins and utilize things like glutamine, as an example, to fuel the citric acid cycle, a metabolic process in the cell to continue to sustain tumor cell growth. So again, people need to understand that this is a very complex problem and that tumor cells are very adaptive. If our cells weren't adaptive, we would not be alive as complex human beings, as complex life forms on the planet Earth.
I agree. Now, deodorant causes breast cancer. True or false?
Currently, it's false. And it's false because we don't have conclusive evidence to say that it does cause breast cancer. And I want to provide some semantics here too, because this is something I mess up as well. Not necessarily deodorant or, things that reduce the amount of odor, like from our armpits, but more so antiperspirants, things that have these aluminum salts in them. They're kind of abrasive to the skin, and over time they can induce cellular damage, which may promote tumor growth. But the level of evidence we have to suggest this is so variable that we can't make strong conclusions. So currently, it's false because we don't have enough evidence to say that it is a causative link to things like breast cancer.
There are supplements that help you prevent cancer. True or false?
Now, if we're saying a supplement is a chemical in terms of a chemotherapy, then true. But the supplements that people hear of when they say supplement, in general, supplement false. So like if I bought, Dave Asprey's bulletproof glutathione, that will not help anyone's disease in general. if I take glutathione as a supplement, or if I take I heard a PharmD recently say that they were taking like sea cucumber extract. There's a company that makes a sea cucumber supplement. It's just a bunch of bullshit that people sell online, or they have a contract with a supplement company and they just regurgitate the crap that the person from the supplement company tells them to. And then they say it online because they have a big mouth. And then, so in general, no, supplements don't help to prevent cancers.
From directly a question from Mark Heyman. Crushed garlic and cooked broccoli have an incredible anti-cancer power. True or false?
False. That's almost entirely false. And one of the things that Mark Hyman was talking about in terms of this, first of all, fuck that guy. And second of all, I apologize for the language here, but I feel very strongly about some of these people, and he's one of them. Continually spouts misinformation online. And because of his massive following, people tend to believe him just because they appeal to his authority or whatever authority he thinks he has as a medical professional. But there are studies that examine, preparation methods for broccoli and things like garlic to have, I guess, enhance the stability of specific chemicals inside the garlic, or antioxidants, specific antioxidants within broccoli or garlic that may help to act as things which can reduce tumor specific characteristics. But that, again, these very broad statements, they don't mean that I should go out and cook broccoli in the heaping loads, or cook garlic in heaping loads and consume an absolute shit ton of garlic or broccoli, and like that's going to assist me nutritionally in reducing my tumors.
Yeah.
So
now, artificial sweeteners can increase the risk of some cancer types. True or false?
If I consume a metric shit ton of artificial sweeteners, they might increase the likelihood, based on the research that's available to us. Artificial sweeteners, if I consume a metric shit ton, may increase the likelihood for specific cancers. But again, based on what we currently know, no human can consume that much of an artificial sweetener without probably dying on the spot from immediate toxicity. So cancer wouldn't be the problem there. It would just be consuming a toxic dose of a specific chemical in high volume. Dose makes the point.
And I guess it also comes to frequency. And like, if you are going to take a carcinogen or something that is going to actually impact the level of risk for you for developing any type of cancer, you would need to be exposed to that carcinogen very, very long time, or plenty enough for that to actually have an effect, right?
Right. Yeah, absolutely. Like, so like if tomorrow, let's say tomorrow, there's this very amazing study that comes out from the National Cancer Institute that determines that aspartame does indeed have a strong correlation or causative link to cancer development as a whole. There's still always going to be this this amount that we can safely consume.
Yeah.
The same is true for cigarettes. The same is true for alcohol. It's just the amounts vary between the different types of substances based on what we know about their abilities to induce tumor formation.
I agree.
So it really all just comes back to the dose of these things makes the poison. And within moderation, I can consume whatever I want. Like, I had a cigar while I was camping this weekend. I consume a cigar maybe once a month now. In general, I've never smoked cigars. I'm having a beer right now. I've had maybe 2 beers this week. You can have these occasional things. People need to understand moderation.
I agree. Now, there is a lot of fear mongering around GMOs and glyphosate and these kind of toxic substances. So they seem to, as a statement, cancer is increased by the intake of GMOs in food. So you should be really careful and choose mostly organic and avoid at any cost any GMO sources. Is that true or false?
That is false. And that's one of those things that's more towards false than it is towards true. And the reason that is because GMOs have enabled us to grow crops and various other things where we shouldn't realistically be able to grow them. And with things like pesticides like glyphosate, which a lot of people complain about, if they do make it into the consumption process, which is very highly negligible, they make it into our foods in a very, very small fraction, that it's like how many parts per billion of the overall substance that you're consuming. So again, everyone can consume a little bit of glyphosate, even if it did make it into your foods. But in general, glyphosate does not make it into food sources. But even if it did, again, it all comes back to the dose makes the poison. But when it comes to genetically modified foods, if we did not genetically modify foods, because of the current human population on planet Earth, there would be a lot less humans on Earth. So it's kind of like this trade-off between a modest risk at best by genetically modifying things to be resistant to pests or things like viruses or bacterial infection or fungal infection, things that they naturally would succumb to in the environment, making them resistant because of genetic modifications, and providing enough food for the human race on the planet. So it's a trade-off, and understanding these these complexities, we can understand that for very modest risks of genetically modifying food, it's far better to have GMO crops than it is not. So
okay. The last question here is about alcohol, which already you mentioned, but is alcohol is a carcinogenic? Is it true or false?
alcohol is a carcinogen. That's true. We know alcohol, any association with alcohol, and there have been multiple studies published by the National Cancer Institute here in the United States, and many studies overall showing that even modest amounts of alcohol can increase likelihoods for specific types of cancers like liver cancers, pancreatic cancers, kidney cancers, those sorts of things. But again, health is complex. So I can consume alcohol in moderation, as long as I understand that there are other things that I'm going to have to do to offset the effects that alcohol may have. Your bodies are amazing at dealing with various stresses. So I can consume a carcinogen. I can go out in the sun without sunscreen and deal with radiation. Our bodies have these things that we've adapted over a lot of time, in the grand scheme of life on this planet, a very small amount of time. But we've evolved these things that enable us to deal with stresses on planet Earth in moderation. And there are things we can do like exercise and balancing out our diet to enable our bodies to take care of the natural stresses that we deal with on a regular basis. But my behaviors can control the amount of alcohol that I consume, the amount of sun that I get, if I'm putting on sunscreen, in terms of protection, the amount of exercise that I have. And this is that fine interplay between genetics and environmental control that we have as humans. But it's also one reason why humans have lived longer than any of our predecessors. You'll see the Liver King often talk about living like our ancestors. If we lived like our ancestors, we wouldn't be here. We'd be dead. So yeah, that's all I have to say about that.
Looking at your top recommendations or your final words to sort of send a message to people who want to live a better life and reduce any sort of risks around developing cancer, or they're very concerned about this for the future, what are some of the things that you probably could summarize or tell them to work on, or pretty much to follow in order to reduce any type of risk? There's always a risk, but what are some of your top recommendations?
I'll try and summarize it in one if I can. And the thing that I try and actively push on my own Instagram is the pursuit of knowledge. Because in knowing, just how complex and beautiful life is, we can begin to understand that there's, again, this recurring theme of balance that we come back to, that enables us to survive on planet Earth. And this is, again, I know this is very broad and it's probably not super helpful, but in understanding all of these complexities associated with what it means to be alive on Earth, we can, in general, make better decisions about how we continue to live. So if I'm aware of the things that promote cancers, or if I'm aware of the things that promote obesity or cachexia, let's say I do get a disease like cancer or obesity. If I'm aware of the things that can prevent it, if I know specific dietary habits that will help reduce obesity, like being in a caloric deficit, but being able to also exercise and consume a nutrient-rich profile of proteins and carbs and fats and consuming fibers, I can, in general, through this knowledge that I've acquired, gain a better understanding about how to live. So a lot of it becomes, behavioral. If you have the intellectual development, you can make better decisions. And that's something that I push on my page. And that's why it's incredibly important we try and simplify things in such a way where the majority of people, or at least can understand what we say, because it's that knowledge that's going to enable true, impactful behavioral changes, which can stimulate overall human health. Ignorance is not the way to go here, and falsely believing these social media influencers just because we're appealing to their confidence in the way that they say things, or their appeal to their authority because they're a doctor is counterproductive to human health.
Projects, future endeavors, something that is what's going on in Joey's life in the next couple of months.
So in the past few months, so I just finished my postdoctoral fellowship at the University of Pennsylvania, where I was studying, thank you. I was studying liver cancer in Dr. Celeste Simon's lab. She's a very well-esteemed professor. But as I've progressed through my academic career, I've realized that I kind of want to shift gears a bit. I've had this full goal of becoming a professor and having my own lab and my own crew. But based on my own experiences and my own behavioral development and logical development, I think that how I've currently transitioned or developed as a scientist, I don't think I'm a good fit for that track anymore. So I was on this track to become a professor and have my own lab in academia, but now I'm transitioning into industry with a sole focus on trying to enhance patient outcomes. So actually, I have some good news. I've been looking for a job the past 6 months, and it's incredibly hard to transition from academia into industry. If you know anything about that, because if you develop yourself on an academic path, you do not appeal to industry at all. So it's been really hard for me to appeal to industry. So I got some good news. I finally got a job at a nearby company in Philadelphia for a contract position called Insight in Delaware. And I'll be doing antibody pharmacology, so along the immunotherapy front, so testing specific types of antibodies to be able to kill cancer cells specifically. So
that's awesome.
So future projects are going to depend on
that,
I guess, how efficacious these therapeutic targets are and these therapeutics are. So we'll see.
That's so exciting.
I'm super, yeah.
Yeah, that's awesome. An amazing pleasure to having you on my podcast. I really wanted you to be here because I know there's a lot of things you want to communicate, and there's a lot we can still continue to talk about. Cancer is a very complex and very deep topic. And for many people it might be very sensitive because of their background or their past. And I think it is very important to tackle this topic as a way to improve your knowledge and also bust some of these myths that are always lingering around. And you're a great person to talk to about this specific topic. So I want to say I could stay here for another hour asking more questions, because the more we talk, the more questions I get in my head. I appreciate you a lot. I'll talk to you very soon.
Yeah, thank you so much for having me. And, I really appreciate it. And I look forward to, continuing this discussion and, helping to address people's questions and concerns that they might have about cancer biology from your own perspectives.
Awesome. Bye-bye.
See you later.